Okay, in our fourth example here, we're going to solve the tangent squared of x equals 3/2 secant of x for x being in the interval from 0 to 2 pi. Right, so in our previous videos, we've been using a variable of theta, right? But really the variable is just what angle we're going to be representing, right? What letter we're going to happen to be using. And if you're more comfortable with the letter x, then so be it, right? You must be able to work with different variables. Okay, so we're going to solve this. So let's go through. We say, hey, I've got a quadratic that's one function and a linear that's another function. So I have tangent squared and secant. Right? So what I can do is use 1 plus the tangent squared of x is equal to the secant squared of x, which is one of my Pythagorean identities. So 1 plus tangent squared of x is equal to secant squared of x. So therefore, what I'm going to replace tangent squared with is going to be secant squared of x minus 1 equals 3/2 secant of x, right? So all I did was solve for tangent squared. That's secant squared minus 1. All right, I personally don't like fractions too much, so I'm going to go ahead and multiply both sides by 2. So 2 times secant squared of x minus 1 equals secant of x. Okay. Next up, hippity hoppity, my distributive property. So that gives me 2 secant squared of x minus 2 equals secant of x. So now this is starting to have a quadratic feel to it. So I'll say 2 secant squared of x minus secant of x minus 2 is equal to 0. All right. So what might I choose for my substitution? I might say let u equal the secant of x. So now I'm going to have this quadratic form. 2u squared minus u minus 2 equals 0. Does this factor? Well, I could come in and try a variety of things, right? So this is prime, so 2u and u. I need a product of negative 2 and a difference of positive 1. A product of negative 2 and a difference of positive 1. So I could try different things in here, see what might work and what might not work. And I might see that, hey, you know, in order to solve this, what am I going to do? And I'll see, oh my gosh, I lost a 3. There should have been a 3 right there. Oh no, right? And those are the types of mistakes you might make. So that should have had a 3 right there. Right, so there should have been a 3 there, which means there should have been a 3 there. Oh, now I need a product of negative 2 and a difference of negative 3. Oh, well, if I put a negative 2 here and a positive 1 there, 2u times negative 2 is negative 4. 1 in u is positive 1, so that'll give me negative 3u, and then minus 2. So, you know what? It does work. You just have to be careful on making sure your work carries through the whole way. So solving here, u needs to be negative 1/2. Solving here, u needs to equal 2. But what does u equal? Well, let's see here. U is secant of x. So that means I need to solve secant of x equals negative 1/2 or secant of x equals 2. Right? But the secant really is just the cosine, so I could say this means that the cosine of x needs to be negative 2, and the secant of x I can say is 1 over cosine, so the reciprocal, so that means that the reciprocal of the secant would be the reciprocal of 2. Then I can look and evaluate, and I can see, hey, this here is going to have no solution, so we can call this extraneous. No solution, right? Because I know that the cosine of x is never equal to negative 2. And for this over here, right, cosine of x needs to be 1/2, right? Well, if I consider the quadrants where I am positive, with the reference angle, I know that my reference angle is going to be pi over 3. So that means that x is going to be pi over 3, or x is going to be negative pi over 3. Right? Positive up here, negative down there. But wait, my solutions need to be between 0 and 2 pi. So negative pi over 3 isn't going to work. Right? Negative pi over 3 does not work for me. Rather, I have to express that solution in the fourth quadrant as x equals 5 pi over 3. So I've got my solutions, x equals pi over 3, and x equals 5 pi over 3, and those are my solutions on the interval from 0 to 2 pi. If I wanted to verify that that was the case, I could certainly come up and graph it on my calculator. Right? Come to y equals, turn on my calculator first, right? So clear my equations. So I've got parentheses, my tangent function, and that's going to be squared. And then I have 3/2 times my secant function. But remember that the secant function really is just, the cosine function, so I could say that's 1 over the cosine, the reciprocal of cosine. So I could say that I have the following to represent tangent squared of x and 3/2 secant of x. Right? My window from 0 to 2 pi, and I want to find if there is any intersection. So let's go ahead and graph, and we'll see if we can see our graphs. And if not, we will need to look closer. So it looks like we may have some intersections occurring, but we may not necessarily be able to see those intersections. So we might need to adjust our viewing window, right? And make our viewing window so that our max values are a little bit larger. So maybe I go to 10 and I'll graph again. And so there goes my tangent squared function first. Notice all the values are positive. And then here comes the 3/2 secant function. So it looks like I have one intersection on the left. It looks like I have an intersection over here. And then it looks like I have another intersection over here. All right. Let me go ahead and find one of the intersections. So second trace. Right, and I can arrow over, right, to hop onto one function or onto the other function. And so there I am, close to one, close to the other, press enter, right, 3 times, and I get, it says about 5.2359. Okay. Now one of our solutions was 5 pi over 3. So let's see what is 5 pi over 3. 5.2359. So we have our solutions, and it does seem that on that interval there are only 2 solutions.